Chapter 4, Dimensioning. What we will learn in Chapter 4. How to dimension, orthographic project, using proper dimension techniques. Key point. Dimensions affect how a part is made or created, okay, or manufactured. Detailed drawings. What good is a drawing without details? It's just another picture. So we need to make sure that we have information to create the part. Orthographic projection, shape description of an object from front, top, right side. A detailed drawing is an orthographic projected part plus dimension specifications needed to manufacture an object. Does that make sense? Why would we need dimensions on a part?
How big it is.
That's it. Size, shape. In fact, the handout that I give you, size and location. That pretty much is a thing that's something we need to remember. Size, location. All right. A detailed drawing example. Looks familiar to you guys. You should be getting used to this by now. Enough information to recreate the part. Dimensioning. Learning to dimension. Now, I know we've been doing a little bit of dimensioning, but we're going to go into a few of the rules. I think this slide has 200 and some slides just in dimensioning. We're only going to get started today, okay? So we're going to cover the first few. Now, I have a question for you. Should we dimension a part exactly the way we draw it in Inventor or in AutoCAD? I see a no. I see a yes. What do you think?
I understand what you're asking.
Are you going to draw it exactly the way you want it to be dimensioned? Maybe, maybe not. You may use planes that are turned off. So, if that's the case, no. They are not necessarily the same dimension required to manufacture it. Here is the thing. When you draw it in Inventor, you're using exact numbers. If it's 1 inch, it is 1 inch. So if you start dimensioning your part and you say, well, I can come in 1 inch from this side, 1 inch from that side, it's going to be right on the drawing. But if you dimension it that way, you throw tolerances in, the distance between the holes may not line up. Does that make sense? So you would dimension it from one baseline to make sure the holes are accurate. You may draw it the other way because it's easier to draw the other way. Does that make sense? But to make it, it's a different story because the person making the part doesn't want to touch off and zero on this side, go over here and touch off zero, or do a lot of math to figure out how far it is from one side to the other. So what they're going to want is from one location. Does that make sense? So you will dimension it different, and you will use standards. Ask me, why 14.5-2009? That is subject to change. They update it every so many years or whatever. But basically that are the standards that parts are dimensioned to. Industry standards, we have them for the U.S., we have them for Europe, and they all kind of go together now. Has anybody seen this? A tolerance block, which has our tolerances and also our projected angle. Projected angle, roughly there's two, first and third. The United States uses third. Europe, Japan, most of those, they use first. And basically what they do is they mirror the part over. So what we would consider the right, they use the left. And it throws us off when we look at it. So just be aware of that. Now, we're going to learn to dimension. We've already been playing with dimensions, but there's some rules that we have to follow. As with everything else in life, we have rules. What are some of the rules? Well, this is the requirement for dimensions. Clear, concise, include everything needed to manufacture and inspect the part. Remember that. That might be important. Clear, concise, and everything that's needed. Okay? Does that make sense? Why would we want it to be clear?
So they can read it.
If it ain't clear, everybody's confused. If you don't include everything, nobody knows what you want. So, those are important. Now, how do dimensions appear? We have to make sure they appear good. Dimensions, appearance, dimensioning and locating features, dimensioning rules. Those are proper dimensioning required knowledge. You need to know what the dimensions need to look like. Does that make sense? Of course it does. You guys got this. Dimensioning appearance. Dimensioning requires the use of dimension lines, extension lines, leader line. And they're all drawn how? Push of a button today, yes. But what type? How are they drawn? Thin. If there's, you want them to look different. What's another way that we can make them look different in an electronic world? Color, yes. A different color. That is another one. Standard is that they're drawn thinner than object line, which makes sense because the object line is more important. That's what's your dimension. But there's also some other important things. Dimension line. A line terminated by arrowheads which indicate the direction and extent of a dimension. Right here. Dimension line. Notice the arrowheads are touching the what lines? Extension lines. Yes, they are. They also have a lot of times a gap for the dimension to go in. Now our softwares will do that automatically, but if we're hand drawing them, we have to leave that gap. Now sometimes the dimension will not fit in between, so it'll either go on the outside or above it. Now let's look at it a little bit. Dimension lines. Ideally the dimension line is broken to allow the insertion of the feature size. That's our dimension. Extension lines. There's a rule down here that's in the blue. Right there. Long extension lines should be avoided. But an extension line is a thin solid line that extends from a point on the drawing to which the dimension refers. Another thing about an extension line, a visible gap. Right here. How big should that gap be? 8. Usually 1/8, 1/16 to an 1/8. Usually 1/16 is what we use. But, you know, it depends on your part. If you got a huge part, like a house drawing, you may want it away a little bit more because it shows up better. But usually it's 1/16 away. That's usually our common, and our software, we set it up, it does it, and you know what? You guys don't even think about it, do you? All that is controllable in the setup of the software under the dimensions properties. Every bit of this is controllable. Now, leader line. What is a leader line?
Arrowhead to dimension radius or
A leader line, it's got arrows and or dots or nothing, but a leader line is usually associated with a note. In other words, it's pointing to something and you're going to tell us something. A straight, inclined, thin, solid line leading to a note or dimension value. If you dimension something as a radius or a diameter, it will throw a leader line a lot of times in AutoCAD or Inventor. Those are leaders, they point to a feature. Now, the rule of thumb is, leaders may be terminated with an arrow if it ends on the outline of an object, the radius. Now, the next one, with a dot or nothing if it ends with the outline, within the outline of the object. That is what the standard is. In 30 years of doing this, I could probably count on one time I've seen it done this way. Because we are lazy or efficient. We're not, most engineers or designers will not change the arrow type. They'll just leave it as an arrow and point to it because that takes extra time, extra thought, extra work, and there's a boss standing over them wondering why the job's not done. So it just slips through. You can call it lazy, or you can call it not taking time, whatever you want to call it. I've seen it very few times in my life. Most of the time, they will leave it as an arrow. So now that you know this, you'll start probably paying a little more attention to it. Yes, hey, that's supposed to have a dot or nothing. But I'm not going to go in and change all these for that because I'm going to use a leader and go to that. That's what's going to happen. So if I'm a mean instructor and I want to count off when you point to something, I can do it. Would I do that?
Probably. In a heartbeat.
In a heartbeat? Probably not. Because I'm more concerned getting you guys ready for the real world, which is not always the same as the book world. Okay? There's people, they're not going to care if you put a dot or an arrow. They just want to know what you're pointing to, fit, function. But the proper way to do it is with a dot. If you want to do it with a dot, there you go. Avoid crossing leaders, long leaders, leaders that are parallel to adjacent dimension, extensions or section lines. In other words, your leader doesn't want to match other lines because it can get you confused. You want them at an angle up. Small angles between the leader and the termination. Little short leaders. It's hard to tell what they're really. You need that a little separation, but not great big long leaders. Don't point to something across the room. In other words, you know, if you're doing a house drawing, don't put your note on the right-hand side when you're talking about something on the left-hand side. Always draw them at an angle, never horizontal or vertical. No, at an angle. Any questions on leaders? Types of dimensions. Now, I give you something, a handout that I kind of like to throw in this. It's not in this book, but it says size, location. Size of an object or the location of an object. That's what dimensions are telling us. Where it's at and how big it is. Does that make sense? Well, they go into a little detail here. It says dimensions are given in the forms of linear dimensions, angles, and nodes. And all of that gives you the size and location with that information. Linear distances. They are usually arranged horizontally or vertically, but may also be aligned with a particular feature of the part. A lot of metric drawings will have the dimension aligned. You just know what that means. In other words, instead of, if you're looking at the drawing horizontal, instead of the dimension being horizontal like we would normally write, it will be facing the part itself. So if you turned it, it would say 10 or 1 inch, and it aligns to the part. Some will do that. I'm not a big fan of it because usually what you'll see people do is they'll turn their head to try to see it better. You know, okay, or they'll turn the drawing because we are so used to reading in a horizontal fashion. I mean, that's just the way it is. But that isn't an accepted way, is a line. But one thing you don't want to do is have them all over the place. Some aligned, some. If you're doing the vertical, which is your vertical dimensions, don't have part of them aligned and part of them horizontal. One or the other. Does that make sense? Okay. Angles. Usually give the angle between two surfaces or features of the part. We learned a little bit about angles today, didn't we? Compound angles will mess with you. So we want to make sure that we're paying attention, because angles are tricky if you start putting compounds on them. As we found out with the part that we drew, that we will dimension a little bit later. That's why we drew the part, so we could have something to dimension. Notes. Used to dimension diameters, radii, chamfers, threads, and other features that cannot be dimensioned by the other two methods. If you can't put a linear or an angle dimension, then you do it with a note. Does that make sense? There is not a linear dimension for 1/4 threads. It's a note. It's all, I mean, it's just the way it is. Exercise. No, that doesn't mean we get up and do jumping jacks, does it? No. What is our exercise? Here we go. Identify the dimension type and line types using the following drawing. The one that is red, what is that? A dimension line. Is that correct? It is. It's a dimension. What is the next one that is red? Extension line. How many agrees with that? All right, let's see. Bingo. Woo, woo, we're on a roll. What's the next one?
Leader line.
Leader line. It is a leader. Hey. Uh-oh.
Dimension type line.
It's a linear. I think it's the way they want it called. I would call it, linear, or I would call it a size. Right? They're not going to ask for size. They're going to ask for a linear dimension, because that's what it is. But I also look at it, is it a size or a location? It's one of those,
I'm going to say size.
Yeah, I will say size. It's the outside of the part. So it's locating the chamfer, but no, I think it's a size. And that's why I want to cover that, so you can get that going. Because now, whoa, go back.
Well, note.
Dimension type. It's a note, but it's a local note. What does local note mean? It's to that specific location. What type of dimension is that over there? Angle.
Note.
It is a note. What kind of note's this one? If I call that one a local note,
Non-local note.
non-local note, can we come up with another name? You guess?
Broad note.
Broad note. What's be another name for that?
Vague note.
Huh?
Vague note.
Vague note. All right.
Well, we can listen to that.
Anybody got? You got it. You've got it, Cody. Come on. Broad, encompassing the whole thing.
All note.
All note, okay. How about a general note? General note, okay. General notes. General notes are used to cover the entire drawing. In other words, note all fillets and rounds 5R, unless otherwise specified. That's a general note. That covers the entire part. Another good general note, remove all sharp edges, deburr all sharp edges. That's a general note, covers the entire drawing. Whereas The local note, diameter of 8, that's specific to that one item only. Does that make sense? Unless it says number of places. It may say diameter 8, 5, or maybe say 2 times 8. So if there's more of them, you can say, but it's still a local. It pertains to one or certain features. Does that make sense? Okay. All right. Arrowheads. Arrowheads are drawn between the extension line if possible. If space is limited, they may be drawn on the outside. Notice I was talking earlier. Notice we have the space for the 20. 10, it gets too tight, so they move it outside, kick it over with a leader line, which these can actually be vertical because they're actually dimension lines instead of leaders, okay? The line just leads up to it, referring to a leader, but it is not an actual leader line. Or you can go on the outside with the arrows and point and put the dimension in between, or also you can put it on the outside if it won't fit in between. Does that make all those kind of make sense to you? Good. Lettering. Back to grade school, learning how to write. Lettering. I think I mentioned this earlier today. Lettering should be legible, easy to read, and uniform throughout the drawing. Uppercase letters should be used for all lettering unless a lowercase is required. Uppercase. 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 Can I say it one more time? Uppercase. AutoCAD has this feature actually that you can go in and right click and it will actually change it to uppercase. That's how often it's done. AutoCAD put that feature in, edit the text, and it's uppercase. You can change it to all to uppercase. If you get to type it, you can change it. You can just, without retyping it. Lettering, minimum letter height is 0.12 in the drawing. Now, some of your notes, some of your title blocks, they will go smaller than that in CAD drawings. But dimensioning, 0.12 or 1/8 of an inch is the smallest you want to use. I prefer a 0.15 to 0.18 a lot of times for the drawings. As you get older, sometimes it gets harder to see some of these dimensions, so you want it a little bit bigger. Symbols. Everybody loves symbols. Symbols are taking the place of notes. Why is it important to use symbols? How many products are designed in the United States? How many products are manufactured? And how many are done overseas? Universal. Universal language. Diameter, sphere, radius, spherical radius, reference dimension, counterbore or spot face, countersink, number of times or places. Universal language. Remember, drawing and dimensioning, it is a language. It's what it is. Alright. Depth, dimension, note to scale, square shape, arc length, conical taper, slope, symmetry. And there is where we're going to stop. Your job now is to dimension your part for your ticket out the door. Yeah, if we have enough time, I know we're getting close on time, but that part that you've created, let's dimension it. All right, very good. Now, I'll kind of help some of you.
B,
A sheet, B sheet, whichever one, that's your choice. I would choose an A sheet probably, and then scale it if need be. Oh, God. Now, let's stay calm. You've got the part.
that shoot. Oh, God, what's happening?
Ain't that? Get excited. There you go. Now remember what I thought, what? Capital letters, very good.
What's the project?
Project could be called dimensioning, if you want it to be, or anything you want it to be. Okay.
Weird shape.
Now, to create a dimension, we can either do drawing, which will probably pick the wrong ones. We're gonna go new. And where's the ones that we opened this up? Did we do that? Open, here we go.
No, do that.
I'm gonna do this one, and I'm gonna go file. Save as a template. Say, now then, when you come back, we'll close it out. Now when I go new, there it is. Now, there you go. So now what you're doing is you're creating your orthographic projection. Your three standard views, front, top, and right. And while you're doing this, I'll ask you a few questions.
No.
Is, why is it important to dimension a part? Anybody got any answer for that one?
What?
Why is it important to dimension a part? Why are dimensions important?
Location and size.
So you know location and size. Very good. How to create the part. What are the three key factors? Clear, concise. What else do we need? Legible. How about information? Enough information to create the part?
Layer, oh yeah, layer.
Oh, okay. Good. Do what? Yeah, you could probably go up, I'd try 8.8. Try 0.8. Let's see, if you take, oh no, base view.
Whoa, 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 whoa.
How's that? That look good? If anybody has any questions, feel free to ask. Okay. Very good.
Teachers and students, pardon the interruption. I have a couple of announcements.